Welcome, geometry students, to Unit 1.4, Angles and Their Measures. You're hearing the voice of Mr. May, and I will be working with you through this particular unit. As always, please make sure that you have your guided notes ready and available because we will be completing them. And without further ado, let's begin. Our learning targets. Learning target number 1. I can define an angle based on points and lines. So we're going to learn the terminology associated with an angle. We are also going to be able to identify angles using appropriate mathematical symbols. So not only are we going to learn what an angle is and the terminology that's associated with it, we're going to be able to identify various types of angles using that appropriate mathematical symbology. And remember, mathematical notation is very, very important in geometry. We're going to increase our level of understanding by beginning to model angles using appropriate mathematical symbols. And then lastly, we are going to use the angle addition postulate, and those that have completed Unit 1.3 may see some familiar terminology in this particular learning target. And then lastly, we're going to classify angles based on their measures. So definitions. Our first definition is of an angle. And an angle will consist of two different rays that have the same initial point. So if we go back to our original terminology from Unit 1.2, you may remember how we would construct a ray and what the initial point of the ray means, and then how we might draw an angle or construct an angle from that terminology. Now we will go back and draw one, but let's finish some of these definitions first. So the sides of an angle, the sides of an angle are the actual rays that are the two rays that actually make the angle itself, that share that initial point. Those will be the sides. And then lastly, the vertex of the angle is the initial point, okay? And the initial point is where the two rays will intersect. Immediately, we can see the importance of remembering and understanding the terminology. From Unit 1.2, we have the terminology of rays and initial point. If you are not familiar with that terminology, you'll have a difficulty in understanding the definition of angle. Once again, with sides of an angle, we have the terminology of rays. Vertex is a new term. However, in order to understand the terminology of vertex, you must also understand initial point and, once again, rays. I'm saying this to reiterate the importance of maintaining your understanding of all the terminology that you will be learning. Finally, another word that we have learned the definition of in terminology, intersect. So all of these highlighted words, except for the two, of course, are definitions, vocabulary words, and terminology that we have learned in a previous unit that is now carrying forward. And so, building from these definitions, we can now go about the process of constructing an angle. So how would we draw an angle? Well, first of all, we know that they have the same initial point, two rays with the same initial point. So we have to draw an initial point. And as always, and actually I think let's stay with the same color scheme that we've used in previous. So here's my initial point, and then we're going to draw a ray. And as you may remember, a ray goes from an initial point to one direction. Now I'm going to give my initial point a name, and remember we name points with a single capital letter, it has to go in a specific direction, and we will say that it goes toward point B. Okay, so there is one ray, but remember our definition says that we have two rays and they share the same initial point. So what I must do is actually draw a second ray from that initial point A, and it will go through another point, and I'll call that point C. So now I have an angle that is drawn from two rays that share the same initial point A. Okay, next, the sides. So if I were to look at the sides, and I'm actually going to underline it with green, the sides. So our sides of the angle are actually the rays themselves. Okay, those are the sides of the angle. And then finally, the vertex. It looks like I've actually written vertex in green already. So the vertex is the same as the initial point. So in this case, my vertex is point A. And so now I have an angle that I have drawn from two rays with the share a same initial point. The sides of the angle are the rays themselves, and we call point A, or the initial point, the vertex of the angle. Definitions once again. Here is a word that we learned in a previous unit, congruent. Congruent means same. And so congruent angles will have the same measure. So always make that association with congruent, a very important vocabulary word in geometry, congruent. So congruent angles will have the same measure. And so the measure of an angle, if we were talking about the measure of an angle, we're actually going to use the measure of angle. And this is the angle. This is the symbol that we will use used for angles. Okay, so anytime we're working with angles, we will use that symbol. Also, and it will always point in the same direction. It will always open in the same direction. When we add the M before it, we are specifically referring, I'm going to write this in a different color, referring to the angle measure. So we're referring to the angle measure when we put the M before it. So without the M, then I'm just saying angle. With the M before it, I'm saying the measure of angle. And so an example would be, if I were to draw an angle once again, and I'm going to use the same notation before. If I wanted to write the measure of angle A, and because I'm referring to a measure, then I could also use equals because I am using measure. If I just want to say angle, if I just want to refer to the angle itself, angle A, then I will no longer use equal. I will use, and I'm going to change the color completely here, I will use congruent. Okay, so this is congruent because I'm referring to the angle itself, and this is equal because referring, this is poor English, I apologize, because referring to a measure. Okay? So now adjacent angles share a common vertex and a side, but have no common interior points. So I'm going to need to erase here for a moment. Okay, so I'm erasing this. And I'm going to once again draw an angle using two rays, and I'm A, B, and C. Now a couple things that I need to clarify. First, interior points. Interior points will be all the points located inside of this angle. And remember that these arrows denote the fact that these rays go on forever. So technically, I would have shading all the way out here forever as far as those rays extend. Those are my interior points. So if I were to place a point inside, and I were to call that point B, I have to change my color here. Point B, we've already got a point B. Let's say point P. Point P is in the interior of angle A in this case. Now the second part is that adjacent angles, so notice that we have a plural, angles. They're going to share a common vertex. Well, what's the vertex of this particular angle that I've drawn? Well, this particular angle is drawn with a vertex at A, so they're going to share the vertex A. So the second angle will move in this direction, and I'll call this D. The interior of this angle I will highlight in blue. So the interior of the blue angle, notice that it does not overlap the interior of the pink. Okay? They have no common interior points. They don't overlap. So adjacent angles, they common vertex, they share the common vertex. They both have the vertex at A. They share one side. Okay, so one side is shared, and their shared side is actually ray AC is the shared side. Okay, there's the shared side. The interior of the two angles do not overlap, so they share no common interior points. So the pink and the blue do not overlap. What is inside the pink is not inside the blue. So having said that, I can also say that point P that is inside the pink is on the exterior outside of the blue angle A. Okay, the area shaded blue, it's on the exterior. So if we have an interior, we have an exterior. And I could put on one more point. I could put it out here, and I'll name it E. And I'm going to name it E because E is exterior to both angles. So there is an exterior point to both angles. So we've already semi-covered these two definitions. At this point, they're going to be mostly review. So if I were to draw an angle, once again, angles consist of two rays. And this is a little crooked, so I'm going to draw it again. Okay, and then I'm going to have my points, and just to show you that it does not have to be called A, B, and C, I'm going to call this X, Y, and Z. And now we need the definition of an interior point. And once again, the interior of the angle is going to be the part that goes forever inside the ray, or inside the angle, I'm sorry, between the two rays. And a point on the interior of it, and I'll call this point I for interior. So this will be point I is on the interior, and it's between the sides of the angle, between the two rays. And then I'm going to also draw a point E, and this is point E that is on the exterior. And so the exterior, I'll actually make yellow, and all of this forever in all directions outside is actually the exterior of the angle. So it's an exterior point if it is not on the angle or in its interior. So technically point X, Y, and Z, because they are on the angle, they cannot be considered exterior. X, Y, and Z are not exterior because they are on the angle itself. So we have the interior at I, exterior at E, but then the entire pink region that I've shaded is on the interior. The entire yellow region is on the exterior. So classifying angles. The method for classifying angles is by their measure, okay? So we're going to classify them based on measurement. We have 4 options. We have acute, right, obtuse, and straight. And it all is based on the degree, or the measure in degrees. Our unit of measurement are degrees for angles. And so an acute angle is going to be an angle that has a measure of less than 90 degrees. And 90 degrees is going to form a right angle. And so before I draw an acute angle, I want to go one below. And I want to highlight 90 degrees. Okay, 90 degrees. So 90 degrees, if you were to have a protractor, and a protractor was laying flat on the ground, 90 degrees would be straight up, a vertical line, okay? So 90 degrees is shown by having a line that goes straight up from the one that is lying flat. So if this were sitting on a protractor on the ground, this would be 0 degrees. This will be pointing toward 90 degrees. So my angle itself would also be 90 degrees. And I denote that by putting a box in the corner of it. That is a right angle. Now, if I want to draw an acute angle, what does it say? It says that it is between 0 and 90. Between 0 and 90. So my acute angle has to be smaller. So if I were to draw an acute angle, I would draw something, and I'm actually going to move this. This was 0. This said 90. And I had this and 90. If I wanted to draw an acute angle, it has to be smaller, and it could be any value smaller than 0. If this were at 0, this would be any number less than 90. So it cannot be, if my 90 degrees were right here to make a right angle, the other side of my other side of the angle must be inside of that 90 degrees to make a smaller angle. It could be any value. It could be 10 degrees. This could be 10 degrees. It could be 20 degrees. It could be 89 degrees. It cannot be 90 degrees. It could be anything less. So a 90-degree angle is a right angle. Anything less than that between 0 and 90 will be an acute angle. On the other hand, an obtuse angle will be larger than 90 degrees, but less than 180. So if I were to draw the beginning at 0 degrees, and I know that 90 is going to be vertical or straight up, right? Then the other side of my obtuse angle has to be something that is bigger. And it could be any number. It could be 160. It could be 155, 179. It can be anything. It just has to be larger than the 90 degrees. And then lastly, we have a straight angle. So there's my obtuse. A straight angle, here's the important word. Exactly. It is exactly 180 degrees. So 180 degrees, if I were to draw an angle beginning at 0, and if I know that vertical, if I know that's my 90 degrees, and I go 90 degrees further, what I'm going to end up with is a line or a ray, actually, because the other side of an angle is a ray that lays flat on the ground pointing in the opposite direction, which means that I have what we call a straight angle, and a straight angle looks like a straight line, and this would be 180 degrees exactly. Notice that the right angle and the straight angle always have the exact same measure. 90 for the right, 180 for the straight, and then acute angles have a lot of values anywhere between 0 and 90, and the obtuse has anywhere between 90 and 180. So there are the types of angles. Once again, we classify by their measures, and measurements. Protractor postulate. Once again, remember that this is a word that is terminology from Unit 1.3, and it simply means rules without having to be proven. Okay, rules without having to be proven. And the protractor postulate says that if I have one ray, once again we have to know that terminology, one ray of an angle that lies on the endpoint, then the measure of the angle can be matched 1-to-1 with real numbers between 0 and 100 at the point where the second ray with the same endpoint lies. That is a lot of information that basically says, if I have a protractor, and I'm going to do my best to draw a protractor. Most protractors look something like this. Over here is the measurement of 0. At the top is always the measurement of 90, and over here is always the measure of 180 degrees. What this is saying, this protractor postulate, it states that if I have one ray that I were to sit on this 0, then I can draw it to anywhere, the other side of the ray, to anywhere along this protractor, and it will match to a degree number value. In this case, it might be 75 degrees. Okay? If I were to draw the other side over here, it might point to a number that is 100 degrees. I can draw the other side of the ray to anywhere, and I will find a number between 100 or 0 and 180 that second ray will match. This section basically says I can find the measure of the ray. So I can find the measure of the area in here, for example, by taking the absolute value of the difference. When I have difference, I know that I am going to subtract. So if I subtract these two numbers, if I subtract 75 minus 0, I know that my angle measure is 75 degrees. That is the method for determining an angle measure. Once again, it's an absolute value. Absolute value meaning that it has to be a positive value. We do not have negative angles. Only positive angle measures. Only positive angle measures. Example number 1, using the protractor postulate. So use a protractor to measure the angle to the nearest degree. Okay, you'll be working that in class with a protractor. So this part will be put on pause for just a moment because that is something that really needs to be constructed in person. However, we do need to write 3 names for the angle. When we name angles, naming angles, so let's do it this way. To name angles, you have a couple of options. First, use the vertex as the name. That's your first option. Remember, the vertex is the initial point of the two rays that they share. This is only possible, big red caveat here, no adjacent angles. If you have adjacent angles, for example, if I had another angle that came out here, and this was point D, I can't use the vertex. Oh, can't use point D. This was point E. I cannot use vertex D as my angle name because you don't know if I am referring to this angle D or if I am referring to this angle D, because both technically have the same vertex. So if there are adjacent angles, I can't use the vertex name. However, in this case, there are no adjacent angles, so I have the ability to write angle D. Remember, that is the symbol for angle. And let's use green. Symbol for angle. Okay. Angle D is an option that works if there are no adjacent angles. Option 2, let's put it in pink. So this is kind of option 2 and 3 because this is both options. It's just reversing the order. And what I mean by that is use the points on the angle. And I must use 3 points. So I have 3 points on the angle. Point C, point D, and point P. So my 3 points, so I can now say angle. Here's the thing, I have to go in order. Go in, or name, let's see, name with points in order. What I mean by that is I have to begin on one side, for example, C. I can't skip over to P. I have to go with vertex in the middle. And then I can go to P. And actually, it would be good practice to add in order with vertex in middle. So I have to name with the points in order with the vertex in the middle. So my vertex is D. D is in the middle. Now I said that the pink number 2 was both 2 and 3. This is why. If I were to also name it using the point D in the middle, using the 3 points, I could also say point P, D, C going in the other direction with D in the middle. So here are the 3 naming options. I can name it with the vertex itself, option number 1. And I know that D is my vertex, but I can only do that if there's no adjacent angles. Option number 2 is named using the points with the vertex in the middle. So if you ever see an angle name with 3 points, you will always know that the vertex is the middle number. That is standard terminology and notation in geometry. I can give you any angle name. For example, angle A, B, C. Where's my vertex? Vertex is the one in the middle. What is it going to look like? It's going to look like this right here. It's going to look like A, B, C. I know that B is my vertex. If I were to give you angle X, Y, Z, you know that I'm going to have a ray, 2 rays with a common vertex of Y. It could go X, Y, Z. Possible, but what is most important? Y is my vertex. Okay? That is the importance of appropriate terminology and notation. So that leaves us option 3, naming the angle moving in the other direction, PDC, D still being the vertex in the middle. So there's your 3 naming options. The angle addition postulate. It states that if the point P lies on the interior of, and this is going to give me the option of naming an angle. Angle, let's say angle X, Y, Z. Okay? So let's draw my angle before we go any further. And that was very sloppy. Let's draw it again. Okay? Where is my vertex? It's the one in the middle. So if I were to name these, I could say X, Y, and Z. And then it says I have to have point P. Point P. And point P is on the interior. Well, remember, the interior is inside of the angle. Well, what I can do is I can draw another ray, okay? Now I'm going to make it a solid line. I can draw another ray through that point, and now I can write the angle addition postulate. And what that says on the angle addition postulate is it says the measure of angle X, remember my naming conventions, my vertex has to go in the middle, but P, okay? So I'm saying this portion here, the measure of that portion there, plus the measure of angle P, Y, Z, okay? I can do that because my vertex is still in the middle, and now I am referring to this portion. So if I add the pink portion, okay, there's my blue portion, here's my pink portion, the pink plus the blue, I will get the value or the measure of the entire original angle XYZ. This is very similar to the segment addition postulate, except we're using angles. We are still adding, only this time we are adding angles. So if I were to say the measure of angle XYP was equal to 5, and the measure of PYZ was equal to 10, and these would be degrees, then I could say that the total, so if this was 5 and this was 10, my total angle would then be a value of 15. Works very similarly to the segment addition postulate, only we are working with angles. So example number 2. Use the angle addition postulate to find the measure of the unknown angle. Okay, so now we have two different angles with two different interiors. One has a measure of 63 and the other has a measure of 27. Okay, so there's our two angles, and let's find what the answer might be. So in this case, it's asking our unknown angle is going to be the measure of angle TSV. So TSV, we're looking for the measure of the larger angle. So how would we do that? Well, what we would have to do is use the angle addition postulate, and we would say the measure of angle TSU, and I'm actually going to, let's do it this way so you can see the distinction. There's the U, and let's call this T, S, and V since they're on the original one. So the measure of TSU plus the measure of angle USV will be equal to the measure of angle, the larger, TSV. So now, let's substitute in the values. TSV is this measure, so we know it is, or TSU, I'm sorry, is 63 degrees. USV is 27. So 63 plus 27 is equal to 90 degrees. And you may recall 90 degrees from our previous terminology is a right angle. We use the angle addition postulate to solve for the unknown angle. Looking below, Q is in the interior of ROS. S is in the interior of QOP. P is in the interior of SOT. And S is in the interior of angle ROT. And the measure of ROT is equal to 160 degrees. The measure of angle SOT is equal to 100 degrees. And the measures of ROQ is equal to the measure of QOS and the measure of angle POT. So now we have to make a sketch and answer the following. So this sounds very confusing, and there's a lot going on here. However, let's just begin with the information that we have. So we know we've got an angle ROS. What do we know about angle names? We know that angle names, and I'm going to erase this so that I have room to work. Angle names, the middle letter is our vertex. So I've got an angle, and I know my vertex has to be O, and the two other sides are going to be R and S. That is the first bit of information. We also know that S, okay, so this S is in the interior of QOP, okay? So we know that O is still my vertex. So I'm going to use the same vertex, but I have to draw a Q and a P that makes S be on the interior, okay? So if I draw, let's see, I have to have S on the interior of QOP. So let me draw a different color. So let's call this one Q. And then we go to O. And here's my P. QOP. Okay? Lastly, we know that P is in the interior of SOT. Well, what's the commonality? O is still my vertex. It's the middle letter in the angle name. However, my angle is now S. So here's my S, same S. O. Now I've got to draw a T. S-O-T. And so finally, this same S is in the interior of R-O-T. Well, just briefly, if I know it's in R-O-T, could I draw my R over here somewhere? Well, no, because S is not between it. So I need to draw my R so that ROT is between, actually I already have my R. Look at that, fortunate enough. I have my ROT. S is in the interior of ROT. We're good to go. So here's my R. Here's my R. And there's my T. There's the O. Fortunate enough, we don't even have to draw another one. So let's use the information. The measure of ROT, the largest angle. So the measure of ROT is equal to 160 degrees. So this largest angle is 160. The next SOT is 100. And ROQ, so ROQ, this little portion in here, is equal to QOS is equal to QOS. We know those two are equal. And it's also equal to POT. So those three, and I'm actually going to change this color so we know all three of those are equal. And so there is our sketch And then you'll have to go about the process of finding QOP, QOT, ROQ, and SOP. So work those. I've got you started with the sketch. Work those, and then in class, you'll actually go through the appropriate answers. But to keep this video a little shorter, I'm going to leave this sketch and then see what you can do on your own. And in class, you'll actually have an opportunity to work the problem together. So now example number 3. So example number 3, let Q be on the interior of POR, angle POR. So once again, we have POR, we have to draw an angle. The interior of the angle is going to be Q. And because of naming conventions, we know that O has to be the vertex, and then we have POR. If I connect my ray, I now have 2 adjacent angles. If I know that the measure of angle POQ, if I know that this angle is equal to 1/3 x plus 1/3, and I know that QOR if I know that it is equal to 2x plus 3, and I know that the total angle, okay, from here all the way around is 5x minus 1, how would I solve for the measure of each angle? Well, we're going to use the angle addition postulate. So my angles that I'm going to be adding will be the measure of angle POQ plus the measure of angle QOR, and that will equal the measure of angle POR. Okay? So let's substitute in our values. So the measure of POQ is 1/3 x plus 1/3 plus the measure of QOR is 2x plus 3. And we know that this will equal the measure of POR, which is 5x minus 1. So from here, we can combine like terms. And combining like terms, this is a like term. These two are like terms. We also have this is a like term as this. And so combining these, we're actually going to convert them. I'm going to convert them to decimals. So we end up with, actually let's use fractions, 7/3 x and 10/3 plus 10/3 equals 5x minus 1. So 7/3 x. What do I need to do? I need to get all of my, let's back up just a little bit. Have to get all my x's on one side. And if I take 7/3, it may make more sense. So as not to have to use a fraction, or to not have to use a negative, better yet, let's actually subtract, rather than subtracting the 5/3, or the 5x, let's subtract 7/3 x from both sides. And we end up with these canceling, and I get 10/3 equals 8/3 x minus 1. I'm going to add 1 to both sides. And so (10/3) plus 1 is equal to 13/3 equals 8/3 x. Now when I multiply, or when I divide a fraction, okay, because I have to divide out that 8/3. So I have to divide by 8/3 technically. When I divide by that 8/3, really what I have to do is I have to multiply 3/8 times 13/3. So dividing by a fraction is the same as multiplying by the reciprocal. And once again, that is algebra terminology. Okay, it's terminology from algebra. And so the answer, when you multiply these two, 3/8 times 13/3 is equal to, reduced down to 13/8. And really what you can do is you could cancel out the 3's and get the 13/8, and that is equal to x. Now, am I finished? The answer is no, because it's asking for the measure of each angle. What I have to do is I have to substitute in 13/8 into each of these values for x. And so POQ is actually equal to 1/3 times 13/8 plus 1/3. And now that I look closely, I see that that was 2x plus 4/3. I did not see that. I'm not going to go back and rework it. I'm just going to mark that 4 out. Okay, I'm going to take the liberty to do that. I was very faded on mine. I am taking the liberty to mark that out. So you may do the same, especially those of you who are confused as to why there was not a 4/3 over here. It's because I just realized that that 4/3 was part of the same problem. So mark that out. We're just going to go with it like it is. So now I have 2 times 13/8 plus 3. And I could do that. The process is the same. The math is a little different. Math was actually probably more difficult not having that 4/3. So process still the same. And then lastly, this would equal to 5 times 13/8 minus 1. So the measure of each angle, if I were to calculate each one of these out, I'm going to end up with 1/3 times 13/8 and plus 1/3. That is equal to 7/8. And then I can also have 2 times 13/8. 2 times 13/8. And let's see, 2 times 13/8. And plus 3. This is 25/4. And 5 times 13/8. 13/8 minus 1 is 57/8. And so if I were to do the math to check to see if I was correct, I wanted to go back and I could say 7/8. So I have 7/8 and I add that to 25/4. My answer is 57/8. And all I'm doing is I'm taking this value, I am adding it to this value, and if my math is correct, then I should get 57/8. I do, my math is correct. So what I demonstrated was the angle addition postulate. Made the math a little harder on myself because definitely did not see that 4/3 there. However, the process is the same. The math will work out to a little bit different angle measurements. However, in the end, all the math was correct. The process was the same, and you can work all of the examples of this nature using the same processes. So, as always, if you have questions, first of all, go back and rewind, look back through the examples, rework them, rewatch some of the lesson, review your guided notes. Then you may also see one of the math teachers. We are more than happy to help clarify any questions or concerns you might have going forward. And as always, we do look forward to seeing you in class.